Hi again, everyone. I'm Trish Triumpho Sullivan, and welcome back for part 2 of the lecture on architecture, art, and science. Okay? Because that's exactly what it is, an art and a science. So we left, when we broke off on part 1, we were talking about the round arch, and let me just see if I can darken that up a little bit so you can see. We had talked about the round arch, and there's that round arch, how a long row of round arches can become a I just forgot what it was called in my old age here. Oh gosh. Don't get old, you guys. That's what happens. See, it's not a good thing. You get old and you forget what things are called, and you have to look up. You know, here we go. It becomes a barrel vault when you have a bunch of them in a row, and then to make an intersection was called a groin vault. Okay, so the round stone arch can span a much larger distance, right? Than the post and beam construction. And when we taught a series of arches supported by columns is called an arcade. So we see that's called an arcade. So here we are at part 2. So the Romans basically used this a lot. They built many cities, roads, and aqueducts all over their territory, which at one point, gosh, it extended throughout Europe, the Near East, and Northern Africa too. So here's an example. There we go. So this example, which I think is a pretty awesome one, let's see if I can darken this up a little bit so you can see that better. There we go. This example demonstrates the amazing feat of engineering and the graceful beauty of the Roman aesthetic. And made of dry masonry blocks, which means no mortar, right? Nothing to stick them together. Some over 2,000 pounds each. The top level carried water, right? And the bottom level was a traffic bridge, so people could walk across it. They could ride their horses across it, take little carts across it. This aqueduct is 161 feet tall. And there were many of these aqueducts all over Europe, many of them still standing and completely functional. Isn't that cool? I mean, consider that these things were made like over 2,000 years ago and they still work. Wow. To me, that's just an amazing thing. They're not used necessarily, and no one's like getting water from the aqueduct anymore. People aren't walking across it. But functional, or possibility of function after 2,000 years, I mean, to me, that's just incredible. That's pretty cool. So the Romans borrowed the Greek column design and paired it with the arch, right? Following their aesthetic and allowing for much larger interior spaces. So they were able to span a much larger width with the arch than they could with the post and beam, which, you know, was limited. The posts couldn't be that far apart. The Romans also invented concrete and were pioneers in its use for architecture. It allowed them to build on a large scale, and concrete was inexpensive, strong, stone-like, and very versatile material. They were the first to use metal reinforced concrete too. Let's move on here. So now next we have the dome. A dome is created when an arch is rotated 180 degrees on its vertical axis. Usually a dome is hemispherical, is an hemispherical vault. Okay, though it can be semi-hemispherical or even pointed. And it's built up from a circular or polygonal base. The weight of the dome pushes downward and outward all around its circumference. So it's usually supported with a cylinder with thick enough walls for the downward and outward thrust. Right. One of my favorite examples of a dome, so here's a dome on a cylinder. Hopefully you can see that okay. We'll see if we can make that just slightly darker there. There we go. Whoops, I tried. There, a little bit darker so you can see the dome on a cylinder. One of my favorite examples of this is the Hagia. And here's the dome on pendentives. So you can see that. And the Hagia Sophia in Istanbul. The Hagia Sophia means holy wisdom, and it was built between 532 and 535 current era. So that's, give or take about 1,500 years ago. As the Eastern Orthodox Christian Church, kind of the Eastern Orthodox Christian Church, which after 1453, when the Islamic conquest was what happened, it was converted to a mosque with minarets. Minarets are towers. The minarets are used to call the faithful to prayer. So it was converted, and you'll see the minarets here up in the back here. You see there's 4 minarets. And originally people would walk up to the very top and call out to bring people to prayer. Let's see let's see here. So here's the interior. It is currently a museum, and its fantastic dome seems to kind of float above the encircling windows. It's really fantastic. Someday I hope to be able to see it in person. The next great architectural advancement was the Gothic Arch. Let's see, there's the Gothic Arch. And while it doesn't seem that different from the round arch, the geometry allowed for taller buildings, and in cathedrals such as the Notre Dame, the use of buttresses and flying buttresses. Let's see if we have a photo of that. Oh, there's the Gothic Arch. So you see it's pointed. This was also used quite often in Islamic architecture, and as some historians theorize that that the round arch was truly Roman, and the Gothic arch was actually an Islamic invention. They were much more advanced in mathematics, geometry, and architecture than the Western world at that time. So there's the Gothic arch, and here you can see the flying buttresses. So they used buttresses and flying buttresses. So the buttresses are these kind of towers on the outside, and the flying buttresses are right here. You can see right there. That enabled spectacular interiors that seemed to soar to the heavens. Buttresses consisting of stone half arches, right? Because you can see the little half arches there that support the walls, also made large stained glass windows possible and gave these buildings a light and airy feel that was missing in earlier constructions. This cathedral was constructed over about 400 years. That's how long it took to build. So let's see, we gotta, whoops, let me go back and we'll look at that. There we go. So yeah, 400 years to build this. It's pretty fantastical. It was completed in 1513, and nothing much changed in architecture for about the next 300 years. Architects and designers basically revised and combined different elements and architectural styles up until the 1800s. So they would just go back and look at historical styles and kind of combine them in different ways, and that was it. So in the 1800s, something really different happened, and that was truss and balloon frame construction. It became viable during the push to settle the western United States, right? We have a lot of pioneers. They're crossing the prairie on covered wagons, and they're coming out west. and they're trying to settle the West and take it away from the natives, right? So that was pretty much what was going on. They put all the native people in the Americas on reservations here in America, right? In other places, sometimes they were held as slaves, but pretty much all the indigenous people in America were marginalized in one way or another. So we have wood being very cheap and plentiful in the Americas, and in North America especially, making trusses out of wood. And these are some trusses here you can see in the background. Let's see if we can lighten that up. Whoop, there we go. That was looking really good for a second there. There we go. So the trusses were made out of wood and allowed for fast construction, even in brick or stone. So even if you had walls of brick or stone, you could easily put trusses up for a roof, and it would really help stabilize the building too. So a truss consists of a triangular framework that spans the outer walls, right, and reinforces or supports the structure. So I'm going to say and or supports the structure, because usually it not just reinforces the structure, but it helps support it as well. Balloon framing was another big deal at that time. So there's a balloon frame. This is something we're really used to seeing now, because this is pretty much how most of our houses are made. It's with a balloon frame. And it was called a balloon frame because naysayers thought it looked too fragile to hold up, and a lot of people didn't believe in it. They thought that anything built with this was surely would just pop like a balloon at the first gust of wind or heavy rainstorm or something. So it became incredibly popular, this balloon framing, because it was sturdy and not as fragile as a balloon, okay? It is probably the most popular method of construction, which made our modern cities in the Western USA possible. Since its invention almost 200 years ago, really. Next, we had cast iron. So cast iron became kind of a bridge between wood and steel construction. So cast iron was started off at the very beginning of the Industrial Revolution in the 1800s. And iron is stronger than wood, as you know. It is more fire resistant, and not completely fire resistant, but it's much more fire resistant than wood. And it could span a larger distance, making larger interior spaces possible, excuse me. So, and more spacious. So you'd have buildings with big spacious interiors like this one behind me, and we'll talk about that. This is Joseph Paxton's Crystal Palace here. It was used for factories. It was used for bridges and railway stations, pretty much all over the world. So we're talking about building with iron here. The Crystal Palace that you see behind my shoulder here was commissioned by Prince Albert, who was Queen Victoria's husband, right? The Victorian era, right? Victorian dresses, that kind of stuff. And if you're old enough to remember, there used to be a big joke about people would say, so you'd call someone up. This is back before caller ID, so nobody knew who was calling. And as kids, we would call someone up and say, hey, you got Prince Albert in a can? And someone would be like, yeah, which at that time was a tobacco, like a smoking tobacco, right, in a can. And it was a brand, Prince Albert smoking tobacco. So they'd say, you got Prince Albert in a can? And someone would say, yeah. And then the kid would say, well, you better let him out, right? So that just goes to show you how easily amused we were back in those days before caller ID. So anyway, it was built by Prince Albert, Queen Victoria's husband, and was designed by Joseph Paxton for the Great Exhibition of 1851. In London. It was constructed with a modular design. So in other words, they made pieces of it in a factory, and then it was assembled on site. And later on, it was actually moved. They had this up for this big exhibition. They took it down and moved it closer over to the palace. Unfortunately, it did burn down. Iron is not completely fireproof, it turns out, right? So this was a pretty monumental building at the time. It allowed them to actually construct it over trees that were already existing. So they actually built it over trees that were there already. And Paxton said he was inspired by leaf structures in nature, that Mother Nature was really an inspiration for him in this. The form follows function idea or concept came really from the Renaissance architect Alberti. And that was what was at play here, this form follows function. And it was later followed by the famous high-rise American architect Louis Sullivan, no relation to me. The Eiffel Tower in Paris, built in 1889 by Gustave Eiffel, right, is an iconic cast iron monument that at the time was the tallest structure in the world. And it is a well-known example of cast iron construction that is still with us today. It's a pretty iconic symbol of Paris. We think of Paris, we think of the Eiffel Tower, right? So our next important innovation, I'm going to say innovation in quotes a little bit, is steel and reinforced concrete. And I'm saying innovation because remember, the Romans first used reinforced concrete over 2,000 years ago, right? Nothing new. All the cast iron skeletons and the imaginative use of this method opened the minds of architects and engineers to developing and using high-strength industrial steel, starting in about the 1890s. Okay, and this idea really took off as a commercial architecture in the form, or as commercial architecture, in the form of skyscrapers. So skyscrapers, right? We're all familiar with that. And after the big Chicago fire of 1871 was put in practice full force with Louis Sullivan, no relation to me, in the lead, virtually inventing the skyscraper. I mean, Louis Sullivan was pretty much the guy for skyscrapers. The earliest examples of steel, let's see here, let me move forward. Here we go. There's Louis Sullivan. That's the Wright Building, and that was built between 1890 and 1891, right? And you can see it's not that big of a building. 1, 2, 3, 4, 5, 6, 7, 8 stories, 9 stories tall, right? So it's not the tallest building in the world by any stretch of the imagination. Right, so that was built in the 1890s. So the earliest examples of steel reinforced concrete construction in Salinas are at the corner of downtown Main and Gabilan Streets. That's the Mcdougal Building. And you know where First Awakenings is now. So if that building where First Awakenings is in and Smokey's Key Service, that's called the Mcdougal Building. And that's the very first example of steel reinforced concrete architecture here in Salinas. It was finished in 1898, and it was the only building in that intersection not destroyed by the 1906 San Francisco earthquake. The other 3 buildings currently standing on that intersection of Gabilan and Main Street in downtown Salinas were built in 1907. And guess what they used? Steel reinforced concrete, just so you know. Just as a quick heads up, Salinas lost about 50% of its buildings during the 1906 San Francisco earthquake. It was very strong. It was an 8.1, I think, on the Richter scale. And the Loma Prieta quake that we experienced here in the Santa Cruz Mountains in 1989 was a 7.1. So every mark on the Richter scale, every full number on the Richter scale is 100 times stronger than the number before it. So the 1906 earthquake was 100 times stronger than the Loma Prieta 89 quake. And most of you guys are going to be too young to know that. But anyone who's old enough to remember, that kind of gives you an idea of why Salinas lost so many of the buildings that we did. However, really quickly, we didn't have the fires, the devastating fires that San Francisco had, and that was a big difference in how many buildings we lost as well. So if you look at those buildings, whoops, sorry about that, folks. Always think I'm going to remember to turn the phone off and don't always remember. So if you look at some of the buildings in downtown Salinas, you're going to see some examples of the Greek and Roman columns from the video you watched. What types are they? We'll talk about that in our discussion. Also, look up egg and dart. It was a very popular architectural element, or design element during this time. So you'll see it all over in buildings in Old Town, and it has a particular meaning, and it goes back. Along with these columns and different kinds of design elements, a lot of it all goes back to the Greek and Roman times, which is pretty interesting. So our very own skyscraper in Salinas is the Salinas Bank building. It used to be the Rabobank most recently, and now they're making it into an apartment building, right? It is in the Art Deco modern style. And Salinas has, just so you know, Salinas has the largest number of Art Deco buildings between San Francisco and Los Angeles, and that's pretty exciting stuff. And the building's about the size of this one that we see behind us. That's the Salinas Bank building, okay? It was constructed to be the tallest building in town, and it still holds that distinction, being just 6 inches higher than its neighbor across the street, the Jeffrey Tower. And the Jeffrey Tower, just so you know, is where Marilyn Monroe stayed when she was in town as the Diamond Queen of Salinas. So these skyscrapers and the young architects who pioneered them brought what is called an international style. And cities all over the world suddenly raised their skylines, right? They started building up higher. And before then, you know, a tall building might have been 4 stories, right? Maybe 5 stories at the tallest. So all cities had a really low profile, a low skyline. And you'll notice that in Washington, D.C., if you ever get there for a visit, or if you've been there, you'll notice that the profile of all the buildings is low, and that's because they wanted the Capitol Dome to be the tallest in the city, that would be seen over the tops of all other buildings. So you don't see high rises, skyscrapers in Washington, D.C. So they developed this international style that raised the skylines, and as skyscrapers loomed higher and higher, really changing the look of our large cities forever and spreading this international style across the globe. Let's see here. Let's see if we can go forward. Here we go. So an innovation of supporting the roof and floors on interior load-bearing steel or concrete columns is called the Domino construction method. And it allowed for more versatile floor plans, and the walls of glass that we think of in modern office buildings now. Right? When we think about big cities and modern office buildings, we often think about them having these walls of glass, right? So only about 50 years ago, new breakthroughs in materials and physics, not to mention computers, brought about cool new ideas that took form in shell structures, such as let's see, okay, well, there's some steel frame construction. Let's see if we can make that a little brighter for you here. There you go, see it a little bit better. So there's some steel frame construction there. So we're looking at shell construction. We just talked about that. So, here's some, I forgot to, so this is the Bauhaus in Germany. And you see that kind of wall of glass. Let's see if we make that just a little brighter for you. There we go. It's got a little wall of glass there. And there you go. Again, that's a Seagram's building in, I think in Chicago. Pretty gargantuan, right? And here we go. So this is a shell structure. Let's see. Let's get this darkened up a little bit for you, so you can see it. So this is the terminal in New York, And so a shell structure and suspension structures work pretty much like tents, right? You can see that little graphic there behind me. And let's say the Jeppesen Terminal Building. Here we go. So there's a suspension structure there. So this is the Denver International Airport, and it's a pretty dramatic use of the suspension technology. Architects and engineers are looking forward to using things like carbon as a building material, like woven carbon. That's kind of an interesting thought. And maybe in the future, right, something, because carbon is a real strong and lightweight material. And after all, woven carbon fiber is already being used for bicycles, airplanes, and even cars, like race cars. Let's look at, so here is Zaha Hadid. She's an amazing and talented female architect. She was born in Baghdad and has gone on to design buildings all over the world, like Cincinnati Arts, Contemporary Center for the Arts. So that's one of the buildings she designed. And Frank O'Geary is another one. He designed the Guggenheim Museum in Bilbao, Spain. He succeeded actually at really relating his work to the museum's original building. There's the Guggenheim Museum in New York City, which was designed by Frank Lloyd Wright and was very innovative at the time. It's kind of round and flowing. And so Frank O'Geary took that idea and changed it completely, but still kind of makes it relate to the original museum. They kind of speak to each other. And Frank Lloyd Wright, one of the most innovative architects of our time, he designed with nature. That was his big thing, and was probably the most influential architects of the 20th century. Basically paving the way for the green building and movement and the 21st century's new crop of radical innovators, right? Among the latest thinking, let's see, we'll look at some. So here's a Frank Lloyd Wright. This is called Falling Water. And it was built over a creek. Isn't that cool? Wouldn't you love to live someplace where you just had a creek flowing and all that really relaxing sound under your feet all the time? So the greenest buildings are the ones that are already standing. That's one of the things that people are thinking about now, is doing. Here's Frank Lloyd Wright. Frank Lloyd Wright was thinking about this a long time ago, doing things that were good within the environment and speaking to the environment. So different types of buildings that heat and cool themselves just by airflow and use of the sun, proper use of the sun, and maybe some fans. And this shows some of the interesting use of energy here, which is pretty amazing. Really cool designs. So they're using thermal energy in some cases from the ground, energy from the sun, heat from the ground and the sun for heating in the winter, and then airflow and green plants for cooling. So that's pretty exciting stuff. So here's one we're talking about using buildings that have already been built and converting them into green buildings, and that being the greenest form of building, so that you have you're not tearing something down and rebuilding it, you're repurposing it. And here's one where they've repurposed wings from a 747 airplane, right? And it really does look kind of cool. It's kind of an interesting idea. And so that's it for the architecture lecture for today. This is part 2, and thank you very much for joining me. We'll look forward to seeing you next time.